Hi there, this is Haley, and I'm going to go over the original equation that we were given. So our equation is not A and B and C, or A and not B and C, or A and B and not C, or A and B and C. So what I'm going to do is walk you through how to simplify this. So to simplify, we are going to use the distributive property to pull out like terms. So as you can see down here, two of the like terms right here are C, and then they've also got A, B, or A and B, and an A and B for both of these. But I also used the associative property when I was grouping these together because it doesn't matter which order they would have been grouped. But for this example, we pulled out the C, so just like above, and we put not A and B, or A and not B. And then it's ORed with A and B and not C or C. So looking at this equation, this portion right here is an exclusive OR. A won't be turned on and then B will be, or A will be turned on and B won't be. And then for this portion right here, you can see the not C or C. And so anything that's not opposite and ORed with itself will automatically equal 1. So this is where the equation has broken down to C and not A and B, or A and B and 1. I used the distributive property. As you can see, we have C and not A and B, or C and A and not B, or A and B. And as you can tell, we're going to pull out like terms again, so that's why you've got the blue under both of these A's. And when you pull out those like terms, it's going to give you C and not A and B, or A and C and not B, or B. So we're going to use that A or not A and B equals A or B. Algebraically, that confused me, but what I did was I broke them down into truth tables. When comparing these truth tables, you can see that they have very similar outputs, but they also have very similar inputs as well. Wherever there is a 1, they will receive an output of 1, but if there is no 1, then it will always be 0. So replacing the parentheses, we now have C and not A and B, or A and C or B. And then with distributive property, the A and C or B and A, and we're going to combine like terms one more time. So I combined the like terms of these two, so we pulled out the C right here, and you can see we have not A and B, or A, or B. So as you can see what we circled for this one, where it's on, we have A that is on, and then you would have C being on since B is off. And the two constants that would be in this circle portion is A being on and then C being on. So that would be one part of our equation. Next, you can see for the vertical one, A is off and B and C are on. And since it's vertical, the constant would be the B and C being on for that portion. So we're going to OR it with our A and C. And then for the very last circled pair, A is on, B and C are both on, but then when you go over, A is still on, but it's only B that stayed on, not C. So what we would do, since the ones that stayed on constantly, for this one, we would do A and B.
This is simplified version, yeah. This is this A, B, or
C and A, or C and B.
yes.
Okay, I see.
Yes. Yep. I used like similar mixture of electrical and hydraulics mixture combined. But this is the power valves here. I draw this diagram. Here is the pneumatic system of how we're going to work it out. If I press A or B, if I press A and B, which is here and here, which I push that bad boy, and then I try A or C. How do I say A or? You gotta watch that. Right? When you watch your language, oh, you gotta go on here. Okay, but you gotta watch it. You do
have to watch your logical language.
Yeah, you gotta watch it because you're gonna confuse your partner a lot really quick. And he's like, "What are you talking about, friend?" And then A and C, that works.
Much better.
B and C also works. Great. Trying C and A.
And Johnny used logical valves.
Logical valves.
He used the
saves
logic
brains.
valves instead of the relay logic, and how much easier was it?
Too easy? So you get it hooked up at the first try.
How long did it take you?
Like